Okay, good morning to students, to all of you. Myself is Dr. Santosh Choudhury and leader in chemistry. Last class, in class number 6, we will discuss about the characteristics of alcohols and the identification of alcohols, that is your primary, secondary, tertiary alcohol, how the primary, secondary, tertiary alcohol is identified, the primary, second, tertiary alcohol identified by the Lucas test or Victor Mayer test, and the primary, secondary, tertiary alcohol can also be identified by the oxidation or dehydrogenation. And last class we discussed about the conversion of methanol to ethanol and ethanol to methanol by various processes. And we have to discuss some uses of methanol and ethanol, what you mean by rectified spirit, what is the absolute alcohol, what is the difference between rectified spirit and absolute alcohol. Rectified spirit means 95% of ethanol in aqueous solution, and absolute alcohol means the 100% alcohol is not isolated. That's why we are taking 99.99% of alcohol is called absolute alcohol. To solve the fuel problems, that is the exhaust test of the renewable resources, that non-renewable resources, that is petrol and diesel. Now the ethanol is used as a fuel by mixing with your gasoline or petrol, that is called power alcohol. And generally the ethanol generally used for beverage purpose to make it unfit to consumption, that is called methylated spirit. That's why a little amount of methyl alcohol is added to ethyl alcohol for industrial purpose. Okay, students. And today we will discuss what is phenol, how the phenol can be synthesized by different methods. So what is phenol? Phenol is the hydroxy derivative of benzene. What is benzene? This is your benzene C6H6, the hydrogen atom, and replaced by OH group. Then we can say this is your phenol, and this is your benzene. So the hydroxy derivative of benzene is known as phenol. The functional group of phenol is OH group. And phenol is different from alcohol. That is, phenol different from alcohol with respect to their properties, that is chemical properties. For example, alcohols are not acidic or less acidic than the water, whereas phenols are more acidic in nature than water. So many properties different because in phenol the OH group, this is your phenol, here this is your OH group, and this OH group bonded to sp2 hybridized carbon atom. Whereas in alcohol, the OH group is bonded to sp3 hybridized carbon atom. And due to it bonded to sp2 hybridized carbon atom, it can exhibit resonance. That's why the phenol is quite different from alcohol with respect to their properties and with respect to their method of preparation. Okay, Like alcohol, phenol also classified as monohydric phenol, means one OH group per molecule, that's called monohydric phenol. And the monohydric phenol is your simply phenol, or the hydroxy derivative of toluene, this is called orthocresol, and this is called metacresol, and this is called what crystal? Paracresol, and this is your OH. Suppose there is a Cl group, parachloro, phenol. You see, all of these molecules containing only one OH group is bonded directly to the benzene ring. Directly bonded to benzene ring. Then you can see it is a phenol. So these are the monohydric phenol. That means the monohydric phenol, the OH group is bonded to benzene nucleus. Or this is another this is your benzaldehyde. The benzaldehyde hydrogen atom is substituted by OH group. This is called salicylal. Dehyde, and this is your salicylic acid, and this is so many compounds. This is called your nitrophenol, but paranitrophenol, and another one of the most stable compound, that is your the OH. This is phenol, and this is substituted by 3NO2 group, and this is called picric acid. It is a very strong acid like carboxylic acid, but does not have any OH group. But does not have any carboxylic acid COOH. That's called picric acid. Okay, these are the all are the monohydric phenol, means the benzene nucleus contain one OH group along with other substituents. Let's come to the dihydric phenol. Dihydric phenol means two OH group per molecule, and the two OH group directly bonded to the benzene nucleus. And dihydric phenol is three types. You see, these are the dihydric phenols because the two OH group bonded to or present in benzene nucleus. The dihydric phenol, this is called catechol, and this is called rishosnol, and this is called quinol. Or we can say this is called ortho dihydroxy benzene. Okay? The benzene is separated by the two OH group. Orthodihydroxybenzene, this can say para dihydroxy benzene, meta dihydroxybenzene, and this is para dihydroxybenzene. Similarly, when the benzene nucleus containing 3 OH group, that's called trihydroxyphenol, and the trihydroxyphenol means 3 OH group present in the benzene nucleus, and OH, is one of the example of trihydroxyphenol or polyhydroxy compound, and the another type of trihydroxyphenol, and this is another one. You see, each molecule have 3 OH group and bonded to different position in the benzene nucleus or benzene ring, and this is called pyrogolal, and this is called hydroxyquinol, and this is called fluoroglucinol. What is called? Fluoroglucinol. And these are the classification of phenol. The phenol are classified monohydric, dihydric, or trihydric according to the number of OH group bonded to the benzene nucleus. Okay, students, let's come to the nomenclature. In nomenclature, there are 2 systems. One is called common system, another is called IPEC system. In common system, common name, just to name is as it is, that is, this is called phenol, and this is called OH. Suppose this is CH3, this is called para. Cresol, because with respect to OH, this position is ortho, this is meta, this is, that's why it's called para. Cresol, and this is called metanitro phenol, and this is called, about this OH, this is your COH, is called salicylic acid. These are the all common name. So suppose what is the IPEC name, IPS name. In IPS name, this carbon atom OH group, it is a 1. Right? So you can say this is called hydroxybenzene, or simply you can say phenol. And this is OH, this is CH3, this is 1, this is 2, that's why 2-methyl phenol. What is this? This one is OH, NO2, NO2, NO2. This is called 2,4,6, 2,4,6, because this is one 2,4,6 trinitro phenol. Suppose if the benzene ring containing the 2 different function group, one must be a OH group, then we can name numbering the OH group according to their priority order. For example, when I name this it is known as salicylaldehyde. Between the OH group and CH group more priority. That's why this is 1, 2, 3, 4, 5, 6. So you can say 2 hydroxy benzaldehyde. 2 hydroxy benzaldehyde because the CHO group is more priority order as compared to OH group. Suppose I will take this one. So if you're not there, you can say it is a acetophenol. What is called? Acetophenol. When the OH group is there, we can say this is 2 hydroxy acetophenol. Okay, these are the name of the phenols in common system as well as IPEC system. But do you know the phenol generally used as a antiseptic or disinfectant agent. The dilute solution, very dilute solution of phenol act as a antiseptic, and little higher concentration of the phenol is called disinfectant. You see, phenol is a disinfectant which contain a phenol is a component. And you know Dettol. Dettol is a chloro derivative of phenol. So the Dettol is used as a antiseptic, and in common name, very popularly, phenol is known as what acid? Carbolic acid. Generally known as, what is commercial name of phenol is carbolic acid. And this carbolic acid generally used as a disinfectant agent. Okay, this is all about your phenol. And phenol is an acidic aromatic compound, and the acidic nature of the phenol we discuss later on. Let us come to the method of preparation. Generally, phenol can be prepared from benzene, diazonium chloride. The phenol can also be prepared from benzene, that means directly or indirectly. We'll discuss one by one. So the phenol from benzene diazonium chloride. In benzene diazonium chloride, what is benzene diazonium chloride? I have already discussed in the synthesis of chlorobenzene, bromobenzene, that is a St-Mary's reaction. The benzene diazonium chloride is C6H5 benzene phenyl, that means C6H5 N2 plus Cl. This is called benzene diazonium chloride, that's called BTC. And this BTC can be synthesized from aniline by diazotization. That means you take aniline, this is undergo diazotization, means treated with NiNO2 plus dilute HCl, at about 0 degrees C, and this group is converted into diazo group, and this gives you N2 plus Cl minus. This is called benzene diazonium chloride. And this benzene diazonium chloride, what produced from aniline, when treated with steam, that is steam containing H2O vapor, and this H2O vapor will react with this one. This gives you phenol plus N2 plus HCl. You see, the phenol can be synthesized from benzene diazonium chloride by the action of the steam. Otherwise, we can convert the aniline to phenol. This is one of the conversion. That means we can prepare the phenol indirectly from aniline. That means the aniline first convert to benzene diazonium chloride by diazotization, and the diazotization it gives benzene diazonium chloride, and the benzene diazonium chloride untreated with steam it gives you the phenol. It is one of the method for the preparation of phenol. Let's come to from benzene. That is, the phenol can be synthesized from benzene so many ways. Suppose this is your benzene. This can be converted into phenol in so many ways. That is, the benzene undergoes sulfonation, then phenol. Benzene undergoes chlorination, chlorobenzene, then you can convert to phenol. Benzene convert to Fidelkraft, alkylation, that means it gives you cumene, and the benzene can be converted to directly phenol. That is called Rasik's method, Rasik's process. So by starting benzene, we can convert to phenol by different way, or by converting into different intermediate compound. That is method of preparation of phenol from benzene. So first is come to benzene. From benzene by sulfonation, suppose you take the benzene, this is undergoes sulfonation, means a sulfonic acid group will introduce into the benzene ring. That is the help of what? Fuming sulfuric acid. The fuming sulfuric acid containing H2S2O7, that is called oleum. That is, fuming sulfuric acid means H2SO4 plus SO3. And that gives you, and this undergoes sulfonation. This gives you benzene sulfonic acid, and this benzene sulfonic acid fused with sodium hydroxide. You fuse this solid sodium hydroxide. You fuse means heating. It gives the salt first. This is called sodium benzene sulfonic acid. When you heat it further, it forms sodium phenoxide. It forms sodium phenoxide. And this sodium phenoxide treated with dilute HCl, it gives you an acidification, gives you phenol. Okay, that is starting from benzene, you convert to phenol by the method of sulfonation. Okay, students. So the benzene can be converted to phenol by sulfonation. Actually, in our book, what is given from this one, benzene sulfonic acid to phenol. Okay, this is one of the method, the conversion of benzene to what? Phenol. Second method, you come to the benzene. This is your benzene. Benzene and chlorination. What is chlorination? Benzene treated with chlorine plus anhydrous ferric chloride. One hydrogen atom separated by chlorine, that is gives you, this is your chlorobenzene. And this chlorobenzene can undergo nucleophilic substitution reaction. What reaction? Nucleophilic substitution reaction when fused with NaOH at high pressure and what? High temperature. This condition. This undergoes the OH group. This became sodium phenoxide. And this sodium phenoxide treated with dilute HCl and acidification. The ONA group convert to phenol. This is your phenol. This is another method, that is the benzene convert to phenol by chlorination. That means the benzene convert to chlorobenzene, and the chlorobenzene is now fused with sodium hydroxide at high temperature, high pressure. The Cl group is substituted by ONA, and the ONA group can convert to OH group by the action of dilute HCl. This is another method, the conversion of benzene to phenol. And another method, these are the somewhat costly method. Another method is convert to benzene to phenol to make it that is third method, the benzene convert to phenol by cumene intermediate. What is cumene? Cumene is isopropyl benzene. Cumene is what? Isopropyl benzene. So the benzene react with either propene or propyl bromide. Propene or propyl bromide. It undergoes Philip reaction in presence of anhydrous ferric chloride, and this alkyl group is gets substituted in the benzene. It gives you what this is called isopropyl benzene. This is called isopropyl benzene, and this isopropyl benzene is known as cumene. And the cumene, and exposed to air, in air contains oxygen, and this get oxidation, means this hydrogen get oxidized. This hydrogen get oxidized to form peroxyhydrate. What you call it is peroxyhydrate cumene, and this is upon hydrolysis, means exposed to the air, and that air it forms one intermediate gas, that is peroxyhydrate, and this peroxyhydrate further reacts with water from air, because moisture content there, it will oxidize to give this is one phenol plus acetone. And this is one of the conversion of benzene to phenol. That is, you starting the benzene undergoes Friedel-Crafts reaction, Friedel-Crafts alkylation by the action of either propene or propyl bromide. It forms isopropyl benzene, and this isopropyl benzene is known as cumene. And the cumene, when exposed to the atmosphere or air, it contains oxygen that first oxidized to peroxyhydrate, cumene or peroxyhydrate, and the peroxyhydrate hydrolysis with water to give phenol and acetone. You see, these are two methods. You will get two important compounds from benzene, that is your phenol as well as acetone. And this is one of the, in large scale, the phenol can be prepared in a large scale. This is called one of the industrial methods. This is one of the what? Industrial method. In large scale, the phenol can be prepared by benzene by making an intermediate. That means the benzene is there and is required either propene or propyl bromide. And this is the another method of conversion of benzene to phenol, and another method is called Rajic process, that is benzene this is your benzene, it react with treated with HCl and oxygen in presence of cuprous chloride, and this will gives you what? It gives you the chlorobenzene, and the chlorobenzene on action of fused with sodium hydroxide at high temperature and pressure, this gives you sodium phenoxide, and this is treated with dilute HCl, this gives you phenol. Another industrial method of preparation, and this process is known as Rajik's process or Rajik's method. And the phenol can be synthesized from chlorobenzene. That is another process that is called dose process. And this is the laboratory synthesis of phenol from benzene. Now, the phenol from chlorobenzene. You have already discussed the two more methods, that is called from chlorobenzene. And the chlorobenzene convert to phenol, that is called dose process. What process? Dose process. In dose process, the chlorobenzene fused with sodium hydroxide at a high temperature and pressure. It gives you, what compound this gives? Sodium phenoxide, and this sodium phenoxide on dilute acidification, it gives you the phenol plus Na. So this is called your phenol. And this part process is called dose process. In last year, that means in 2020, in CHSE, one of the question is there, how can you prepare the phenol by dose process? In dose process, the chlorobenzene is fused with solid sodium hydroxide at high temperature, high pressure, particularly 200 atmosphere pressure, about 500 degrees C. Then the chlorobenzene undergoes nucleophilic substitution reaction to give sodium phenoxide, and the sodium phenoxide is acidified with HCl. It gives you phenol. Okay, the phenol can also be synthesized from salicylic acid. So what is salicylic acid? That is orthohydroxybenzoic acid is known as salicylic acid, and this is your salicylic acid. This salicylic acid heated with soda lime. What is the function of soda lime? This group get lost as a carbon dioxide. This became sodium phenoxide. This is your sodium phenoxide, and this phenoxide treated with dilute HCl, this gives you phenol. That is, from the salicylic acid you get also what? Phenol. And these are the various methods of preparation of phenol. So next come to the properties. The properties of phenol. Properties of phenol. First come to the physical physical properties. It is a colorless, crystalline, solid or viscous liquid. Okay, with characteristics phenolic order. Very characteristics phenolic order. Have you seen the Lifebuoy soap that contains amount of phenol? And that smell is called correct phenolic order. And second is, it is highly corrosive and highly poisonous in nature. What is a corrosive? Corrosive means when the phenol comes in contact with your skin, it will be corrode, it became blackened, it can burning. That's why phenol is highly corrosive. We can say, sir, phenol is not a corrosive because the phenol contains very low concentration of phenol, near about 0.05%. If you contact a direct phenol, that is a corrosive and poisonous in nature. Third, it is sparingly soluble in water because the phenyl group, what is the phenyl group? That is C6H5. The phenyl group dominate over the what group? OH group. You know the phenyl group is hydrophobic group. What group? Hydrophobic group means not affecting toward the water, whereas OH group is hydrophilic group, affinity towards water molecule by forming hydrogen bond. And this OH group is dominated by the phenyl group. That's why phenol is sparingly soluble in water, but readily soluble in organic solvent like alcohol, ether, benzene, so many things. Now, what about the melting point and boiling point? The melting point and boiling point, the boiling point of phenol more than benzene or any other aromatic compounds with comparable molecular mass. With comparable molecular mass. Because the phenol molecules are associated together by forming hydrogen bond. By forming what? Intermolecular hydrogen bond. That means this is your phenol. What's the angular shape? This is another molecule of phenol. These are angular shape, and this possesses fraction in negative charge, this possesses fraction positive charge, and this is your intermolecular hot bond. Hydrogen. That's why phenol has more boiling point or melting point than the corresponding aromatic compound, or than the aromatic compound with comparable what molecular mass. Okay, students. Next, come to what happens when the phenol exposed to air. When exposed to air, the what is actually phenol is what? Colorless. Phenol is what? It is what? Colorless solid. When exposed to atmosphere, exposed to air, it turns to brown. It turns what? Brown color. Why it turns to brown color? It turns to brown color. Why it turns to brown color? Because the phenol, this is your phenol, when exposed to atmosphere contain your oxygen, this get oxidized to form a compound that is called benzoquinone. That is, the phenol undergoes aerial oxidation. Phenol undergoes what? Aerial oxidation. When exposed to atmosphere, it converts to another compound that is called benzoquinone. What is called is benzoquinone. That's why actually phenol is colorless. But due to contain some amount of benzoquinone, that's why it turns to what color? Brown color. Generally, the phenol is prepared as a colorless, but exposed when you store in a bottle, generally store in a brown color bottle, but it turns to brown and very corrosive, poisonous, penicillin water, and highly poisonous and highly corrosive. That's why the handling of phenol is somewhat difficult. Okay, these are the some physical properties of phenol, and next class students will discuss about the some chemical properties. In chemical properties we will discuss the acidic nature of the phenol and the acidic strength, and what type of phenol is more acidic and what type of phenol less acidic than the original phenol. And we will discuss some reaction, the reaction of phenol due to the OH group, the reaction of the phenol due to the benzene ring, and some name reaction just like your Riemann-Tiemann reaction, which is most important in phenol, and you will discuss some certain Baumann's reactions. So many types of reaction are there. Okay. Today we will discuss what is phenol, and phenol is nothing but the hydroxy derivative of benzene. The hydrogen atom of benzene nucleus gets substituted by what? By the OH group. And we have to name the phenol in common system as well as in IPEX system. In IPEX system, the OH group, the carbon bearing the OH group termed as 1. That is, according to the other position, we can name this phenol. And we will discuss the method of preparation of phenol. Phenol can be prepared from benzene diazenyl chloride. It can be prepared from benzene by various methods, by sulfonation, chlorination, Rajik's process, and by forming the cumene. So many methods are there. And phenol can also be prepared from chlorobenzene, and that process is called Dawes process. And we will discuss some physical properties of phenol. And phenol is known as what acid? Commonly known as what acid? Carbolic acid. What acid is called? Carbolic acid. Okay, student, this much today. Thank you.